I would like to share with you today is the Polydentate Ligands. Dear children, myself Dr. DIGNA VARGHESE. In metal coordination chemistry, the term complex means a central metal ion or atom surrounded by a set of ligands. All metals from all blocks of the periodic table can form complexes. The metal atom or ion, the Lewis acid in the complex, which is the acceptor atom. Ligand. A ligand is an ion or a molecule that can have an independent existence. For example, a complex, that is the cobalt complex, that is hexamine cobalt 3 ion. In this particular complex, cobalt is the central metal atom which acts as a Lewis acid that can accept electrons from the surrounding group of atoms or ligands. So ammonia is the electron donor. So it is act as a electron donor or a Lewis base which donates electrons to the Lewis acid. Another example is Hexa Aqua sodium ion. In this particular complex, the ligand is water molecule and the central metal atom is sodium. So here we can once again define a ligand is an ion or a molecule that can have an independent existence. The atom in the Lewis base ligand can forms the bond to the central metal atom is called the donor atom. Here the nitrogen is the donor atom in the cobalt complex, and in the sodium complex the oxygen is the donor atom. Both oxygen and nitrogen have lone pairs of electrons that can donate electrons to the central metal atom which acts as a Lewis acid. Here the ligands act as a Lewis base, that is an electron donor. The ligands directly attached to the central metal ion form the primary coordination sphere of the complex. For example, the hexamine cobalt 3 ion, this is the primary coordination sphere of the complex in which the ligands are directly attached to the metal ion. The number of ligands attached directly to a central metal ion is called the coordination number of the central metal atom. The coordination number of the cobalt in this particular complex is 6. As in solids, a wide range of coordination numbers can occur, and the origin of the structural richness and the chemical diversity of the complexes is the ability of the coordination number to range up to 12. The number of ligands in a complex depends on the size of the central metal atom, the steric interactions of the ligands, and the electronic interactions between the ligands and the metal ion. These three factors mainly depending on the number of ligands which can be attached to the metal ion and form a complex. The coordination number of a metal atom or ion is not always evident from the composition of the solid. That means, for example, the X-ray diffraction of cobalt chloride 6H2O shows that a neutral complex, that is its molecular formula is COCl2OH2 4. In this particular complex, the coordination number of cobalt is 6 because it is attached to directly with 2 chloride ions and 4 water molecules. So there are total of 6 ligands attached to the cobalt atom and 2 uncoordinated water molecules. Here you can see the two water molecules which is present on the lattice side. That means it is merely act as a solvent molecules, lattice water molecules, and that species are potentially ligands but not directly attached to the cobalt atom. So these molecules are fill spaces within the structure and not have any direct bonds with the metal atom. So the coordination number of a metal atom or ion is not always evident from the composition of the solid. That means CoCl2 6H2O is its composition, but the complex formula is CoCl2 OH2 4, and the remaining two water molecules is present as a lattice water molecules in the structure. It is not a potential ligands that not have any direct bonds with the metal atom. It means that it is simply acts as a solvent molecules that fill the spaces. Such additional solvent molecules are called solvent of crystallization. The crystal formation requires these two water molecules. Then only it forms a crystal. So these types of solvent molecules are known as solvent of crystallization. Dendicity. It is represented by kappa, the Greek letter K. It refers to the number of times of a ligand bonds to a metal through non-contiguous donor sites. Many ligands are capable of binding metal ions through multiple sites, usually because the ligands have lone pairs on more than one atom. Dendicity means the number of ligands can attach to the metal atom, that is coordination number, but dendicity means that in a particular ligand there is one donor sites that can donate lone pairs of electrons to the metal atom. For example, in the case of ethylene diamine. Ethylene diamine, we know its molecular formula is NH2 CH2 CH2 NH2. Here the nitrogen, here another nitrogen, here two hydrogens are also there, and here two hydrogens are also present, and these first nitrogen can donate 2 electrons to the metal atom, and other second nitrogen atom can donate 2 electrons to the metal atom. Density of ethylene diamine is 2. So it can attach metal atom through these two nitrogen atoms. Types of ligands. Here you can see a general representation of a complex. We know complex always written inside the square bracket, and first we can see the metal atom, and next we can see the ligand, and in which the N represents the number of ligands. So here metal, and next one is ligand, and N representing the number of ligands attached to the metal atom, that is its coordination number. And ligands can be classified into different types. Here we are representing some types of ligands. First one is unidentate or monodentate ligand. Other one is polydentate ligands. In this video you can see only these types of ligands, that is both monodentate and polydentate ligands. Others can be discussed in next videos. Polydentate can be bidentate, tridentate, tetradentate, pentadentate, hexadentate, and so on. Another type of ligand is ambidentate ligand. Other one is chelate, and the other one is macrocyclic, and the other one is flexidentate ligand, and other type of ligand is bridging ligand. In this particular video, I am going to discuss the polydentate ligand, monodended ligand or unidentate ligands. Some of the ligands have only a single donor pair of electrons and will have only one point of attachment to the metal. Such ligands can be classified as monodendate. This word is coming from the Latin word that is one tooth. Here you can see the ligand attached to the metal atom. Only there is a single donor site is here for this particular ligand, or it can donate one pair of or one lone pair of electrons to the metal atom. Such type of ligand is known as monodendate ligands. Examples for monodendate ligands, you can see the amine ligands, that is formula is ammonia, and the donor site in this particular molecule is nitrogen, and the number of donors is only one donor here, so it is a monodendate ligand. In the case of aqua ligand, that is water molecule, H2 is its formula and oxygen is its donor site, and here only one donor is present. Another monodendate ligand is bromido. Bromide ion is the formula Br minus. Br is the donor atoms, that is bromine, and number of donor site is 1. Another one is carbonato. CO3 2 minus is its formula, and oxygen is its donor atom. Here we can see both carbon and oxygen is present, but oxygen is the potential donor. It can sometimes it bind to the metal with one donor site, that means one oxygen atom coordinated to the metal atom. In some other cases it can act as a bidentate ligand, because in this particular oxygen case the two oxygen atoms can donate to the metal atom, so it acts as a bidentate ligand, or it can have a two donor sites instead of one, but here only one donor site in the case of monodendate ligand. Another ligand is carbonyl. CO, it's its molecular formula. In this particular compound, carbon is the donor atom and number of donor site is 1. Chlorido, Cl minus, chlorine atoms is the donor site and one donor site is there. Another monodendate ligand is cyanido, Cn minus. Cn is the donor atoms and one number of donors is 1. And fluorido, F minus. F, here one donor site. In the case of hydrido complex, hydrido is the ligand, H minus is its formula, donor atom is hydrogen, number of donors 1. Hydroxido means OH minus, oxygen is the potential donor and 1 is the donor site. Irido, I minus, iodine atom is the donor atom and 1 number of donor atom is 1. Nitrato, NO3 minus, oxygen is the donor atom. Here it can act as monodendate or bidentate depending upon the number of oxygen atoms attached to the metal atom. This is similar to carbonate ion. Another one is nitrito, NO2 minus kappa O. That means oxygen is the potential donor atom and here only one donor site. Nitrito, NO2 minus Kn or kappa N. This means that nitrogen is the donor atom and number of donor site is 1. In a monodendate ligand, always 1 is the number of donors. Oxido, O2 minus, oxygen is the potential donor and 1 is the donor number. Another monodendate ligand is pyridine. Its molecular formula C6H5N and PY is the abbreviation and nitrogen is the potential donor to the metal atom, so it's a monodendate ligand. Sulfido, S2 minus is the formula. Sulfur is the donor atom and 1 is the number of donor site. Thiocyanate kappa S. In this, SCN minus is the molecular formula. Sulfur is the donor site. Thiocyanate kappa N, NCS minus. Nitrogen is the donor here and 1 is the number of donor atom. Thiolato RS minus, sulfur is the donor atom and 1 is the donor number. Tricyclohexyl phosphine PC6H11 3, that is PCY thrice, that is PCY3, that means its abbreviation, and phosphorus is the donor atom which is coordinated to the metal ion and 1 is the number of donor site. Trimethylphosphine PCH3 thrice, PME3, that is phosphorus is the donor site similar to above case and 1 is the donor site. Triphenylphosphine PC6H5 thrice, PPH3, phosphorus is the donor atom and number of donor site is 1. Polydentate ligands. Many ligands are capable of binding metal ions through multiple sites, usually because the ligands have lone pairs on more than one atom. In the case of monodendate ligands, the ligand attached to the metal atom through one donor site that we have already seen, and in that particular atom there are only one donor site which contain one lone pair of electrons which can donate to the Lewis acid site, that is the metal atom in a complex. But in some other ligands which are capable of binding metal ions through multiple sites, that means the ligand have lone pairs on more than one atom. Ligands that have more than one point of attachment are classified as polydentate. So polydentate ligands can be defined as ligands that have more than one point of attachment. Polydentate ligands can form chelates. First polydentate ligand is bidentate ligand. In this, Lewis base which donate two lone pairs of electrons to the central metal atom. That means ligand which can donate more than one pair of electrons to the metal atom. Examples are acetyl acetonate. Its formula is, you can see in this table, and the abbreviation is AC minus. Here the donor sites are oxygen. You can see from the table the two oxygen. Acetyl acetonate contains two oxygen which can coordinate to the metal atom. So it acts as a bidentate ligand, here in which you can see two donor oxygen atoms. Next one is 2,2-bipyridine. The formula is you can see in the table, and the abbreviation is BPY. Here you can see the nitrogen is the donor atoms which can coordinate to the metal atom. So it is a bidentate ligand. Carbonato. In this particular carbonato molecules, you can see the carbonato C double bond oxygen, and here two oxygen atoms. These two oxygen atoms coordinated to the metal atoms. So it can act as a bidentate ligand. Sometimes only one oxygen atom coordinated to the metal atom. At that time it can act as a monodended ligand. Here you can see the another examples of bidentate ligands. In this case, bis diphenyl phosphinoethane. In this particular compound, phosphorus is the donor atoms. Here two phosphorus atoms, and it can be attached to the metal atom. Another one is bis diphenyl phosphomethane. PH2P CH2PPH2. Its abbreviation is DPPM. Phosphorus is the donor atoms here. Ethylene diamine NH2CH2CH2NH2. Both nitrogen atoms can be act as the donor atom. So it is a bidentate ligand. Its abbreviation is EN. Glycinato NH2CH2COO minus. That is glycine, we know NH2CH2COOH. And its abbreviation is GLY. Here nitrogen and oxygen act as donor atoms. So one nitrogen and one oxygen is attached to the metal atom. Another example is oxalato. Its formula is COO minus COO minus. Abbreviation is OX. Donor atom is two oxygen atoms. Negatively charged two oxygen atoms. So it's a bidentate ligand. And nitrato ligand NO3 minus. Here, like carbonato compound, you can see nitrogen, the two oxygen atoms coordinated to the metal atom. So it acts as a bidentate ligand. If it acts or coordinated to the metal atom with one oxygen atom, then this particular ligand acts as a monodendate ligand. Tridentate ligands. Tridentate ligands have three lone pairs of electrons, and these three donor atoms can be attached to the central metal atom or ion. For examples, diethylene triamine. You can see the formula of diethylene triamine. The donor atoms are nitrogen. The three nitrogen atoms can be attached to the metal atom. So it is a tridentate ligand. Imino-diacetic acid IDA. Its structure you can see COOH, CH2NH, CH2COOH. Here the donor sites are one oxygen, another oxygen, and nitrogen. So two oxygen atoms and one nitrogen atom can attach to the metal atom. So it's a tridentate ligand. Another one is terpyridine. Three pyridine molecules are joined. So you can see these three nitrogen atoms can coordinate to the metal atom. Another one is 1,4,7 triazacyclononane, takin. It is a asa crown ether, that is NH, NH, NH. These three nitrogen atoms can be coordinated to the metal atom and form a tridentate ligand. Tetradentate ligands. Molecules with 4 donor atoms are called tetradentate ligands. For example, tetraazacyclotetradecane, in which the 4 nitrogen atoms, you can see from its formula, there are 4 nitrogen atoms. These can be attached to the metal atom. So it is a tetradentate ligand. Its abbreviation is cyclam. Another one is triamino triethyl amine. Its formula is NCH2CH2 NH2 thrice. Here you can see 1 nitrogen, 2nd nitrogen, 3rd nitrogen and 4th nitrogen. These 4 nitrogen atoms contains lone pairs of electrons that can be donated to the metal atom. So it is also act as a tetradentate ligand. Another one is tris-2-diphenylphosphinoethylamine. Its molecular formula or structure is given here, and in this particular compound you can see 3 phosphor atoms. 3 phosphorus atoms which can donate electrons to the metal atom, and also 1 nitrogen atom. So it is a tetradentate ligands with the donor atoms 3 phosphorus atom and 1 nitrogen. So it is a tetradentate ligand. Another one is tris-2-aminoethylamine. Its structure is NH2 CH2 CH2 N CH2 CH2 NH2 CH2 CH2 NH2, and in this particular compound there are 4 nitrogen atoms that can be coordinated to the metal atom. So these ligands act as a tetradentate ligands. Another important tetradentate ligand is heme. You know, heme is a substance that is a precursor to hemoglobin, which is necessary to bind oxygen in the bloodstream. Its structure is shown here, and you can see these 2 nitrogen atoms and these 2 nitrogen atoms can be coordinated to the metal ion, that is iron in the case of hemoglobin, and forming a tetradentate ligand. Another important tetradentate ligand is corol. A corol is an aromatic organic chemical tetrapyrrole. Corol is very similar to porphyrin that is present in chlorophyll and hemoglobin, which is also an organic macrocycle but has 20 carbon atoms and is found in hemoglobin and chlorophyll. So a corol is an aromatic organic chemical tetrapyrrole system which is very similar to porphyrin ring system. And here also you can see the 4 nitrogen atom NH, 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 N. These 4 nitrogen atoms can be coordinated to the metal atom. So these are known as tetradentate ligands. Pentadentate ligands. Pentadentate ligands have 5 donor sites or 5 lone pairs of electrons to the central metal atom or ion. Examples are tetraethylene pentamine, Here you can see 5 donor sites. This nitrogen, third nitrogen, fourth nitrogen and fifth nitrogen that can be coordinated to the metal atom. So it is a pentadentate ligand. Another one is ethylene diamine triacetate. Here you can see triacetate group. One is here and one is here, and the second one is here, and the third one is here. So it is a triacetate unit containing ethylene diamine, and in this particular compound, one oxygen, second oxygen, third oxygen attached to the metal atom, and fourth nitrogen and fifth nitrogen can be attached to the metal atom. So it acts as a 3 oxygen 2 nitrogen pentadentate ligand. So pentadentate ligand is a ligand which have 5 donor sites. Hexadentate ligand. Hexadentate ligand is that Lewis base which donates 6 lone pairs of electrons to the central metal atom. In for example, 1, 4, 7, 10, 13, 16, hexa, oxa, cyclo, octa, decane. It is a crown ether and its abbreviation is 18 crown 6. 18 crown 6 means 18 is the total number of atoms. Here you can see we can start with this oxygen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So total number of atoms represented as 18. Then it is just like a crown, so it is written as crown, and 6 is the number of oxygen atoms. These 6 oxygen atoms coordinated to the metal atom, so it is a hexadentate ligand. Another hexadentate ligand is ethylene diamine tetraacetate, that is, you all know EDTA, ethylene diamine tetraacetate. Here 4 oxygen atoms and 2 nitrogen. Here 2 nitrogen and 4 oxygen atoms that donate electrons to the metal atoms. So ethylene diamine tetraacetic acid and 18 crown 6 act as a hexadentate ligand. Heptadentate ligand. Lewis base which donates 7 lone pairs of electrons to the central metal atom. Here you can see a heptadentate ligand says ligand contain donor size 1, 2, 3, 4, 5, 6 oxygen, 7th oxygen. These all 7 potential donors can coordinate to the metal atom. So it acts as a heptadentate ligand. Octadentate ligand. Lewis base which donates 8 pairs of electrons to the central metal atom. For example, EGTA. EGTA is ethylene glycol bis beta aminoethyl ether N dash tetraacetic acid. This particular compound is also known as ectasic acid. EGTA has also been used experimentally for the treatment of animals with cerium poisoning and for the separation of thorium from the mineral monazite. It acts as a chelating ligand like EDTA. In this particular compound there are 8 donor sites, that is this oxygen, and this nitrogen, this oxygen, and this nitrogen, and this oxygen, and this oxygen. So there are 8 potential donor sites which can donate 8 lone pairs of electrons to the metal atom. So it acts as a octadentate ligand. Thank you for your attention.